Hello and welcome back at my channel. You will be able to find that under a new name as a FINET link, that stands for FISI network link. After we saw the IPv4 addressing in three parts where we discussed about the IPv4 structure with network portion, host portion, and the subnet mask. We even saw the IPv4 unicast, broadcast, and multicast. We even explained the IPv4 address public and private, and we even explained the network segmentation and how you can create subnets. And based on that, we saw the subnetting using the traditional segmentation and with variable length subnet mask. So based on those, we will do some practice today. So what we will do is that we will find the subnet mask and the connection with the prefix length. We will even be able to find the network IPv4 address for a random IPv4 address of a host, and then we will be doing subnetting based on the traditional or standard subnetting and using the variable length subnet mask. By recalling back the information that we got from the IPv4 address in part 1, we said that the IPv4 subnet mask is used to differentiate the network portion from the host portion of an IPv4 address. And when an IPv4 address is assigned to a device, the subnet mask is used to determine the network address of the device. And we know that the subnet mask is the same size as the IPv4 address with 32 bits, and it has 4 octets, and all the bits at the network portion for the subnet mask will be 1, and the bits at the host portion will be 0. We recall back that we discussed about the prefix length, and the prefix length is a method for writing an IPv4 address by mention even at the subnet mask for that address. And the prefix length is the number of bits set to 1 in the subnet mask. It is written in slash notation, which is noted by a forward slash followed by the number of bits set to 1. Therefore, we have to count the number of bits in the subnet mask and prepend it with a slash. So, depend on that information, let's see two examples. At the first example, we have the prefix notation as 20, which means that the subnet mask will have 20 bits as 1 by starting from the left to the right. So we will start from the first octet and writing down the ones as much as it is shown in the prefix length. And after doing that, we will convert the binary format to the decimal format for finding the subnet mask. So based on this, we have the subnet mask in binary, and if you see, we started from the left to the right by adding ones as much as it is shown in the prefix notation. So there are 8 plus 8, 16 plus 4 at the third octet. They stand for 20 bits. Same for the prefix length. And then the other bits will be as 0. So, and if we go to the subnet mask in decimal format, we will be with the subnet mask 255.255.240.0. Same is for example 2, where we have the prefix notation for as 29, which means that we will have 29 bits 1, and the rest of the bits will be 0. And again, we start from the left to the right by adding ones in each octet as much as it is shown in the prefix length notation. And if you go there, you will see that there are 29 1 bits and the subnet mask, and if you convert that in the decimal format, you will be able to have the subnet mask as 255.255.255.248. How we convert from binary to decimal or from decimal to binary format, we have done that in a video about the number systems. In this case, we will do the opposite. We will have the subnet mask in decimal format. We will convert it to the binary format, and then from the left to the right, we will count how many ones are at the subnet mask, and then we will find the prefix. So let's go with the example 1, and we have the subnet mask in decimal format 255.224.0.0. We have to convert that at the from decimal to the binary format, and we will have this subnet mask. And if we count the bits from left to the right, we will be able to find the prefix notation as /11. Let's see another example, and here we will have the subnet mask in decimal format as 255.255.190.0, and by converting that to the binary format, we will be able to have this subnet mask, and then by counting the ones, the bit 1 at the subnet mask from the left to the right, we will be able to find the prefix notation as /18. In this slide, we will be able to find the network IPv4 address of a host if we have his IPv4 address and the subnet mask. For finding that, we have to convert both of the IPv4 address of a host in the binary format, same for the subnet mask, and then by using the logic AND, which says that both inputs need to be true, so that even the output would be 1. In this case, we have to say that the bits at the IPv4 host address and the subnet mask should be 1, so the result will be 1. By using that, let's see 2 examples. Let's go with the example 1, and we have the IPv4 host address in the decimal format 192.168.30.12. We convert that at the binary format, which is shown in the second line, and we have the subnet mask in the decimal format 255.255.240.0. We convert that in the binary format in this form, and by doing AND bit per bit from left to the right, we will be able to find the IPv4 network address. And if we do that, the IPv4 address will be 192.168.16.0. And let's go to another example, and in this case we have the IPv4 host address 192.168.24.108, and this is shown in the binary format. We have the subnet mask 255.255.255.224, and if we do the AND logic from left to the right bit per bit, we will be able to find the IPv4 network address, and in this case will be 192.168.24.96. So let's go to subnetting, and first we will go with standard or traditional subnetting. For doing the practice with that, let's suppose that we have an IPv4 address provided by the Internet Service Provider as 172.16.0.0/21, and we have our network of the corporate with 5 branches and 4 side-to-side connection between those branches. And by the IPv4 address provided by the Internet Service Provider, if we convert that in the binary format, we will be able to see the subnet mask, and by recalling again that the subnet mask shows the network portion and the host portion. So the bits that stand for 1 show the network portion, and the bits that show for 0 show the host portion. And the IPv4 address, as it is shown here, and the network and host portion, it is shown here. Like that, we can see that there are 11 bits that stand for the host portion. With this, we will be able to connect 246 hosts. For creating subnets, we have to borrow bits from the host portion of our IPv4 address provided by the Internet Service Provider. And for that, with those bits that you can borrow and the bits that will be left from the host portion, you will be able to identify how many subnets you can create and how many hosts you can connect for each of those subnets. The formula for subnets that you can create is with base 2, in this case, exponential by the number of bits that you can borrow, and the host that you can connect for each subnet will be 2 exponential by the number of bits left at the host portion minus 2. We say minus 2 because 2 addresses will be provided for a specific purpose as IPv4 network address and the IPv4 broadcast address. Let's write down again the IPv4 address provided by the Internet Service Provider, the subnet mask, and the network and host portion. By writing down only the IPv4 address and by checking our corporate network with 5 branches and 4 side-to-side connection, we see that it will be the building A with 52 hosts that will define the host bits needed for subnet and how many bits we will need for connecting those 52 devices. And if we go to our IPv4 address provided by the Internet Service Provider, we know that we need 6 bits from connecting 52 hosts, and the rest of the bits at the host portion will be borrowed for creating subnets. And based on the formula for how many subnets will be created in the host that will be connected and each subnet, we will have 32 subnets that we can create by borrowing 5 bits from the host portion, and we will be able to connect 62 hosts per subnet. And this will be the subnet scheme after we will borrow the 5 bits for the subnet and 6 bits will be left for the host portion with 62 hosts per subnet and 32 subnets. And as you can see, by borrowing those 5 bits for creating subnets, we go from the subnet mask /21 to /26. And here in this table, it is listed the IPv4 address of each subnet from the first subnet to the 32 subnet. And then now we will be able to provide each IPv4 address for the subnets that we have for our network corporate. And then we will see that from the first subnet to the fifth subnet, we will provide them for the LAN connection for building A, B, C, D, E. And those 4 subnets here will be for site-to-site connection between those branches, and all the rest of the subnets will be available for the corporate network if want to extend, and there will be a unused IPv4 address ready for the network expansion. Based on the subnet scheme, this will be the network of the IPv4 for our network corporate. But let's analyze the site-to-site connection subnets. And here we will show the network, subnet, and the host portion as it is shown with these colors. Let's have the for subnet for the site-to-site connection as it is shown here, and you can see that we will be able to connect 62 hosts for each subnet, but we will need only 2 IPv4 addresses for the host, for the gateway of the router 1 and the gateway of the router 2 for each interface. So with this, we will have 60 IPv4 addresses wasted for subnet. And since there are 4 subnets, we will have 240 IPv4 addresses unused that cannot be used in the future, since between site-to-site connection we will need only 2 IPv4 address hosts. Since we don't want to have as much as unused IPv4 addresses for site-to-site connection, and by focusing again at the subnet scheme, what we will do, we will provide the first fifth subnet for the LAN connection for each branch, A, B, C, D, E branches, and then we will not use from the 6th subnet to the 9th subnet for the site-to-site connection between branches, but we will let them available until to the 31 subnet for future expanding corporate network, and we will go to 32 subnet, and what we will do, we will subnet that further, and that we will create subnet with another subnet mask, where the subnet mask will be much bigger, and that's why we use variable length subnet mask. We can create subnets with different subnet masks. And let's write it down again, the IPv4 network address for the 32 subnet. And since for the site-to-site connection we will need only 2 IPv4 address available for host, since the host that will be connected there will be the interface of each router for site-to-site connection, and 2 IPv4 address for the specific purpose for the network IPv4 address of that network. And for the broadcast address, we will need 2 bits available at the host portion. So we will borrow 4 bits to create subnet, and we will go to the /30 subnet mask by leading us to 16 more subnets, and by creating those 16 more subnets, let's see the subnets that we will be able to create. So as I mentioned, we will borrow 4 more bits, and we will create 16 subnets, and here will be the IPv4 address for each subnet that will be created by borrowing those 4 bits. And as you can see, the subnet mask went from /26 to /30, and at those subnets we will use the first 4 for the router-to-router connection at our corporate network. And after we subnetted our network with the variable length subnet mask, this will be the addressing assignment scheme for our corporate network with the table listed the subnet mask, the network address, range of host addresses, and the default gateway address for each subnet mask. For the branches and site-to-site connection. And thank you for being with me. See you to the next session. Do not forget to subscribe at our channel Finet link and hit the notification button to get notified for the new videos that will be uploaded. Thanks again.